Okay, today, welcome to flip number 5. We're going to be talking about the law of conservation of mass. So your key question today is, what is the law of conservation of mass? Okay, so before we sort of talk specifically about the law of conservation of mass, I want to talk a little bit about chemical reactions. And chemical reactions are the rearrangement of atoms to produce new molecules. So here you can see we have lead nitrate, okay, and then potassium iodide. Okay, and so these now, what happens in a chemical reaction is, as we learned in role of electrons, the electrons are trying to become happy. So they're trying to get those full outer shells, those full valence shells. So what happens here with something like lead nitrate, all these individual atoms have rearranged themselves this way to create those full outer shells. Same with potassium iodide. If you remember, potassium has 1 valence electron and iodine has 7. So iodine would like to gain an electron and potassium would like to give one up. So those two bond really nicely together. However, sometimes because of energy or because of how we rearrange things, molecules will like to be with other things more. And so what happens is when you put two chemicals together, we create two new chemicals. Okay? And so here you can see the reactants are the two chemicals that are originally together. And then what happens is when they react and create these new chemicals, we call those the products. So the reactants are here, the products are here. Right? So the reactants are what are going to react, and the products are what are produced. And this is a chemical reaction. It all has to do with trying to fill those valence shells and rearranging the molecules. So just to review, these guys on the left-hand side, the things that are reacting, we call them the reactants. And the molecules on the right, the things that are being produced, we call them the products. So the number of each atom is always going to be the same on each side of the equation. Nothing is gained or lost. You're not creating new atoms, you're just rearranging everything. And so because of that, right, if I sort of take each individual atom and add them up on each side, you've got 2 potassium on each side, you've got 2 iodine, 2 nitrogen, 6 oxygen, and 1 lead on each side. You don't lose any elements, you don't gain any elements in this. And so they're always all there. And so the mass of that entire thing stays the same. The only time that might change is if, for example, a gas is produced and you're not keeping it contained. So if it's lost, that mass may change. But of the things that are reacting, the mass of all those elements stays the same. There's nothing gained or lost there. So that's the law of conservation of mass. You're conserving because it's staying the same, you're keeping everything there, and the mass is what you're conserving. So you're conserving that mass, and it's a law because that's always the case. A lot of times in science we have these exceptions to laws, not in this case. The law of conservation of mass will always hold true unless that gas is produced. Okay? But if you keep it sealed, so you keep that sealed in a container, and you're going to see that in the lab, that gas, it will still have mass, and it will keep that there. So you will see that in the lab, and we're going to prove the law of conservation of mass when we get to the lab on Friday or Monday, depending on your class. Okay? So I just want to show you quickly here using this simulation. So here, this is a reaction of nitrogen gas and hydrogen gas, and it produces ammonia. So this is called a synthesis reaction. Okay? This is where you have two reactants, and it produces one product. So here, I have a nitrogen, I have a hydrogen, and I want to produce ammonia. But you'll see here, ammonia has 1 nitrogen in it and 3 hydrogens. If you look at the left-hand side, the nitrogen gas hangs out in pairs, so there's always 2 of them. And hydrogen always hangs out in pairs as well. So right now, I have 2 nitrogens, 2 hydrogens on the left, but only 1 nitrogen and 3 hydrogens on the right. So this doesn't work. So we need to now create this balance. And so we do that in this way. So I need at least 2 nitrogens over here. So I'm going to create 2 ammonias. And that leaves me with 6 hydrogens on this side, right? 1, 2, 3, 4, 5, 6. And so I'm going to add 6 on this side. And so you can see now that balance. I have 2 nitrogens on the left, 2 total nitrogens on the right. I have 6 total hydrogens on the left and 6 total hydrogens on the right. Okay? If I look at another reaction, I'm looking at sort of the breaking down of water. Okay, water is H2O, so 2 H's and 1 O. And hydrogen again, travels in pairs, as does oxygen. Okay? So now again, I've got this imbalance, and you're always going to have, to create this, there needs to be a balance between the two. Right? So if I'm going to create O2, it means I need two O's over here. I've got two O's, but now I have 4 hydrogens, which means I need to create 4 hydrogens over here. And again, so now you have that balance, hydrogens, 4 hydrogens, 2 oxygens, and 2 oxygens. Okay, a bigger example, this one's huge, right? You've got a lot going on, but in the end, you're always going to have the same number of each element on the left as you have on the right. So if I have, start with 1 of everything, okay? All those molecules. You see now oxygens, there's 2 here, but I have 3 over here, right? Hydrogens, I have 4 over here, I only have 2 over here, and carbon, I have 1 on either side. Okay, so if I add a hydrogen here, or a water, I now have 4 hydrogens, which matches this. Okay, and now I have 2 oxygens here, 2 oxygens here, so I need to make sure I have 4 over there. Okay, so again, you have that balance. It doesn't matter who they're paired with, okay, depending on the reaction. The key is that those atoms are accounted for, the same number of atoms are accounted for on both sides. And that's that conservation of mass. There's no gaining or losing. Okay? So hopefully you've been taking good notes. You're able to answer now the question on Verso. And good luck in the lab. And good luck as we start getting ready for the test. Thanks, guys.